Hey everyone, it's Scott Norris here. VMware's just been some awesome announcements, the ones I'm really interested in and obviously going to be spending a lot of time with is the VMware Cloud Automation Services. So these are new services, SaaS services that have joined the VMware Cloud family, and this is Cloud Assembly, Service Broker, and CodeStream. Now I'm going to be walking through Cloud Assembly today. Now if you look in the description, I've put a link to my blog post which gives some more detail, maybe answer some questions about the product's direction, where VRA in this product sits, etc. But this is truly awesome. It's leapfrogging every CMP out there. It's truly cloud agnostic, and obviously a lot more developer friendly. So let's have a step through here. Now there is so much to it, but I'm just going to really cover an overview, and obviously I'm going to have plenty more videos, plenty more blog posts, and going into more depth and detail as more features and functionality. And I really can't wait to see what people do with this platform. So let's step in here now. So I'll be using some VRA references while I do this video because a lot of people are familiar with them, just to sort of marry things up and where they sit. So right now I've got cloud accounts. Now these are your endpoints essentially. These are the entry points to what we want to automate and provision. So you can see as of now under initial availability, this is what we have, and it's Azure, AWS, VMC, obviously, vCenter, NSX-T, and V. Now, within these cloud accounts, you really just supply username, password, and you select, in case of clouds, you select the region that you want to support, or regions. You can have multiple. And in terms of vCenter, you select the data centers that you want to control. So in here, we look at my AWS here, and we can see we got access key, access secret, and we select which region we want. So I've got my local region select here. You can have one or many selected. Now what that's going to do is obviously then surface up all the availability zones and everything else within there. And we can see on vCenter, this is my personal lab, vCenter. It's going in and I've selected my single DC. I've only got one in there, and I've also married it up with my NSX endpoint to show that they're related. So to get to vSphere, you have what is a data collector. So this is really just a proxy that it uses to grab your information, the machines, the clusters, the details, as well as sending building requests. So once we've set up our cloud endpoints, we move to cloud zones. So cloud zones are, in a rough sort of equivalent terms, are reservation. For lack of a better reference. But this is where we can set up the different zones. So these will be availability zones, for instance. But we can see here, we put our capability tags. So this is leading into the cloud-based provisioning engine that Cloud Assembly has. And this is what makes, the choices of where your workloads will be based on tags. If there's no tags, it'll just round robin and go through all of them like that. See our placement policy here, default is round robin, the rest of them are located here. Spread will try and spread the load. But then we have our compute. So in the case of AWS, we've got our availability zones here. Now I'm not using C at all. It's available, but I haven't put any tags against it. I put a tag, I'm really only going into A, but if I wanted to go into B, I'd use availability zone B. But we can see that we've got all these. Now these will inherit the hierarchy of the tags from the parent, and we also assign it to a project. So think of a project as in a VRA term, a business group. So we assign users, and we'll go to this projects now right here. We assign users who've got access to the project. We assign cloud zones to a project as well. And within here, we can add our cloud zones. We can add more. You can add less, and this is where we can do governance around projects. So that's slowly coming in, but the idea is costings around projects and being able to control which data centers and where they can provision, etc., etc. So this is it's leading to some pretty cool stuff. So the cloud zones, and in case of a vCenter, you choose the cluster or the resource pool or whatever your breakdown happens to be. You choose that. So we can see again, I've got tags. We'll look at compute, and they're all my resource pools, clusters, and a single host in there. And you can see I'm only really using my main cluster here, and that's because it's got the tags on it. Now, moving into that, we've got flavor mapping. So this is the start of the agnostic machine provisioning. So you can add a new flavor mapping. It can be anything you want. So flavor is very open stack sort of reference, but we can choose small, medium, large. You can name them whatever you want. You can see I've named mine Scott Small, and in that we can add our regions within here, our counts. So you can see that I've got AP2 here, I want a T2 small. I've got Azure, I want a A1 V2, and within my data center, I want 1 CPU, 2 gig of RAM. So we can see that all them are referenced to a single flavor mapping. So I can reference this Scott Small in my blueprint, and meaning it will translate to all these. And obviously as more come on, we can add additional ones. I can add additional regions in here, and so forth. Or I could just have one. You don't need to have them all in there. You could break them out individually if you wanted to, but that sort of defeats the purpose, right? So moving on from that, we've got our image mappings. So very similar to flavor mappings, except it's for images. So as you see there, I've got Scott CentOS, and I'm using this AMI within AWS. I'm using this marketplace image in Azure, and I'm using my CentOS template within vSphere. Now, these you can use custom images like I am here. You can use marketplace images as well. And as you type in, I can go here and you'll actually get, the whole list of them. You've got 7,644. So, you can see all of them in there. And same with vSphere, I'll be able to see all my templates that I have within there. So that's really cool. So I cancel that because I don't want to save that. Just make sure that didn't save. Yeah, cool. And then we move on to network profiles. So this is how we determine, very similar to VRA with network profiles, this is how we determine, which network a machine's going to land on, for instance. So if you look at AWS, for mine here, we can see again, you can put top level capability tags on there, which I haven't done, not for the networks because I don't really use the networks yet. I'm keeping it fairly simple. And we can see that I've got 2 subnets within AWS. One's my public, one's my private, and we can see I've tagged that appropriately. So if I want a machine go to private, I would have a constraint on that machine as network zone private. Network policies, now I don't have any set up here, but these are your on-demand network creation. So we can choose, a network domain that I want it to go to. I can choose an external subnet that I want to be a part of, and I can give it a size. And then that's what we use to create networks on the fly. And very similar, security groups, you add your security groups, and away you go. Now I've only got the default in there because that's all I need. I'll cancel that because I don't want to save it. And story, if we actually have a look at vSphere here, just to show the difference within them, is that we've got networks are essentially our port groups, and you can see that I've tagged that here, and this is the default for the zone. But if I was to add a additional network in there, we'll be able to see all the different port groups I have within that endpoint. And you can add them all in, and you can give them different tags, and based on the tag depends where the machine lands. Same network policies. So here this is talking about automatically standing up NSX networks. I've said yep, this is my transport zone, this is my CDR, this is my subnet size, external networks cluster, and the edge data store, wherever that's going to be. And I haven't got any set up, but they're your NSX security groups. Cool. So storage profiles are really no different to network profiles at the end of the day. They're just, what do you want your storage to be? What do you want it to land on? So in case of like say Azure, for example, is that we can, select the storage type, whether we want managed disks, unmanaged disks. We can have premium or standard. We can have OS caching, data caching. We can support encryption, and we can give it a tag too. Now I'm just using managed disks, no tags. That means all my machines are going to fall into that. Very similar, AWS, for instance, you've got a lot of disk types to choose from. So some of those would be your GP2, your IO1 drives, and your instant stores. So you can go, GP2, there's the cold hard drives, we've got magnetic disk, optimized throughput. If we change it to IO1, what's our max IOPS? We want to support encryption and capabilities. So, this is where you go, if I spin up a high performance workload, I need to, be able to put it onto an IO1 drive, and you'd tag it appropriately so that your workload would fall onto that drive. And that's it for the storage profiles. Now I'm not going to talk about the resources, I'll talk about them later, but let's now dive into the blueprints, because that's the really cool stuff. Right, that's just that infrastructure tab is very similar in a lot of ways to the infrastructure tab as VRA, obviously, but with sort of different concepts there. Alright, let's have a look at the blueprints. So the blueprints in here, I'm just going to choose my basic one here, which is a single machine, a network, and a load balancer. Now what we can see, I'll just shrink these, is that we've got cloud agnostic components, we've got vSphere specific components, we've got AWS specific components, and you can see there's more than just VMs there. Lambda, S3, RDS, EMR, KMS, Azure components, and we've got Puppet there for a configuration element at the moment. Now, right now I'm using cloud agnostic, and you can see that if I bring a machine over, it'll automatically write that YAML on the right hand side. Same as if I was to delete that machine, it would disappear from that side. So this is really cool because you can drag and drop, create the structure, or you could write it out cold on the right hand side and you would actually see it start to draw. Very similar, I could, delete all that. That didn't go away. Delete, 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 delete all of that, and then I could put it back in there and you see it draw back. So it's pretty cool stuff. It obviously allows you to keep your YAML in code. You can cut and paste into a lot of cool stuff, but obviously when you go to use CodeStream and the other ones, now they all interact together. All the services, CodeStream, Service Broker, and Cloud Assembly can all be used independently, but they're obviously interconnected if you use them together, meaning that we can actually submit a blueprint as YAML file directly through Cloud Assembly to do provisioning via CodeStream as an example. So it gets really powerful, the whole better together story there. So in here we have we can see on the YAML on the right hand side we've got our inputs. So this is the count, and we can see that's referenced, whereabouts is it? I don't think I've got a load balancer, cloud machine, platform, name. Oh no, I took counts there, 1. So what that would be would actually be $ input, and you can see it, or it does all these for you. Name. Oh, that's the wrong one. Where's my input? There. Input. Count. That's it. Meaning that value will go there. We can also see that this cloud machine here, not cloud machine here, is linked to that network, which is my network.name, and our network, if we select here it is my network, and the name is crawling. So we can see that's how they all link together. Now you can unmap those, and you can see that removes that network constraint, and it's now blank there. I can then drag that back to that network, and we can see it actually draws that in there automatically for us, which is cool. So what this will do, I'm going to and I always should say 2 platforms. So this is my constraint, and we can see here I've got constraint here based on tag, and it's for the import platform here. So I'll put that as my default, but I've done an enum here, which is basically allows us to have a drop down. So we're not even dealing with forms yet. All that's in Service Broker, and those, used to custom forms and stuff out of VRA, that's all still there, and we can service these blueprints up through that. This is just from the provisioning screen, and we can see we can deploy directly from the canvas, which is really cool. We can also version here, and we can actually look at our version history of these, and we can see we can view the diff and everything between them. So you can look at the diff. I've actually got none here. We can clone, we can release, etc. You can visually, there's no difference between the current draft and version 1, but if I was to, let's demo that, go and add another machine, and maybe we'll put a volume here and connect that cloud machine up to that volume, and that's pretty much saying that I want a 10 gig drive attached to that machine. And we go to version history, we can see current draft diff against version 1, and it will come up and show us the diffs, and we can actually view it visibly, and it shows us the difference. So it's pretty cool, So let's go back on that. Let's change this back. Delete. Cool. Alright. So what we're going to do here is deploy, and I want to deploy to AWS. So let's choose a name. I'm going to Scott. AWS crawl, because we're learning to crawl. We go next. We only want one. I don't want a cluster here. Platform AWS, perfect. Hit deploy. Now that's going to throw us into the deployments tab up here, and we can see here, now this deployments tab is pretty much a combination, again using a VRA reference, of the request tab and the items tab. So we can go into this, we can see the topology, we can see any custom values that's been put in, and we can see the history. So these are all the things that it's doing and creating. Now this is really cool. So we can see that it's allocated here. So I can click on these little buttons here, get thrown to the requests under the infrastructure tab, and it'll actually show us which platform it picked and why. So you can see here, there's my request. These are the request type, provision, flavor, image. That's my constraints. It was for this project because that's what I've been assigned. And we can see that we've got here the AWS, the vSphere, and Azure. We can see both of them, all 3 of them match the flavors, all 3 of them match the images. Great. But then we get down here and we can see that the zone aggregated, that's right, that's got a green around it, and we can see Southeast 2A, platform AWS, and it's deployed there. But we can see that these hard constraints here were not matched on any of them, which is why they weren't chosen. You can dive even further in, go into dev mode, and actually see every single thing that it did across the way while looking at the stage info. So I'll go there, and yeah, it just keeps going. If you really want to troubleshoot or wonder what's happening, you can dive really deep in there. So we'll go back to our deployments. We can see that that's still going. We can go back. Oh no, it's finished there. So if I look into AWS, we'll hit refresh. Oh, there's our Tango machine there. And we should be able to see, it's given a public of 222. Let's have a look. Yep, there it is. That's it. And if we go to our load balancers here, we should, nothing's actually on it, so it probably won't be active. But we should be able to see the load balancer when it loads. Oh, about time. There, we can see that the instances, it's been attached automatically for us. It's out of service, obviously. And yeah, so then what we can actually do too is go, okay, well, we can delete here. But say for instance, I go, okay, well, I want to deploy this again, but I want to go, Alright, let's deploy. I want to go and update an existing deployment. I'll choose the one I just did. Go next. I want 3 instances. And I'll actually say that it's going to add 2 more instances and update the load balancer. Now we could, if we were to add a RDS in there, we'd see that it adds all that. It would all be mentioned here. We will remove instances. It would say it will be deleting instances, etc. So it's really that immutable infrastructure. It's meaning that if we update something, we can push the update to the existing deployments, and it will change based on that. The changes we have made, it will do the difference. So I'll deploy that, and we'll see that will get updated. Now, while that's actually going, let's deploy this to Azure and vSphere, the exact same template, blueprint, and we'll deploy this. We'll go short Azure, cool. Go next. We'll choose Azure. I'll hit deploy. Now it's going to go off, and then right at the same time, let's do vSphere. Why not? Hopefully it all works. vSphere. Alright, next, and vSphere. Boom. Alright, so they're deploying. Now, we can see that our AWS crawl there finished. So it's added the additional machines. You can see it's shadowed there. You can see the update. It's put them in there. So let's go and have a look here. Now, that should now have 2 additional instances on it. Hey, look at that. Work like a charm, and the additional instances are in there. Cool. So again, that all worked. Same difference if we were to change it up a bit and go, okay, well, let's go deploy this again. Select update existing deployment. Let's do crawl. I'll go back down to 1. So it's going to delete cloud machines and update the blueprint. Yep, done. So that's going to go and do that there. So I'm just sorting this just so we can see my deployments, since this is a shared environment. So we'll go, I'll wait for these to finish. Now in Azure, we should be able to go into here. Hey, there's a Tango machine it's currently creating, and there's vSphere. So it's currently creating within vSphere as well. So that is good news. So it looks like it's all working a treat, and we can see if we go into here, again, you can look at the history, you can see its allocation. So dive into here, see why it chose where it's going, chose vSphere platform, awesome. Go back to our deployments. Awesome. So they'll just continue. There's our AWS one. So again, they should now be gone or terminated, and our load balancer should now only have 1. Cool. So you can see the difference, especially with VRA, is that we can redeploy over the top of other deployments, and it's truly cloud agnostic. So what I've done here, exact same blueprint. All I've done is change the input constraints, and it's gone to Azure, AWS, and vSphere. While that is a simple example, let's dive into some of the other blueprints. Now this is just a load balancer and a machine with a single network. Maybe you want more than that. So let's just have a quick look. Now I won't dive into this. There's going to be plenty of videos that I'm going to cover going forward, especially as this platform matures and additional features, even additional endpoints, etc. get added. But let's have a look at etcd. So this is again a very simple machine, but it's actually installing an app. So I'm installing etcd, the key value store, and we're using Cloud Init. So at the moment we can utilize Cloud Init to do the installs. As you can see here, I'm actually cloning down some scripts from Git. I'm running them, I'm setting the firewalls, I'm creating the service and everything else in there, and that actually ends up being a nice and up and running working key value store. If we go, okay, let's do it like a more of a PaaS type example. This is actually starting to use some of the other components, and we can see that this is actually cloud specific. So this is always going to go to AWS in this instance, but we've got, you know, the WordPress in here. We've got the RDS instance that we want to cover, and you can see how we bind with the $ brackets to all the different inputs and variables and all the rest, and we've got our cluster there. So that works like a charm, and you know, it's utilizing the instead of having a machine for a database, we're actually using a cloud service in its stead. And we can go even further and go, you know, Spring Trader. You've probably seen my videos on NanoTrader with release pipeline, doing automated testing and all the works. Spring Trader, here I've done this through VRA, I've deployed to AWS through VRA, I've deployed to vSphere through VRA, deployed to Azure through VRA, but I've needed different blueprints for each one of those, right? This is actually completely agnostic, meaning that I can deploy this to Azure, vSphere or AWS with only changing a tag, which is really awesome. We've got our 4 networks, we've got our load balancer, we've got a TC server, and again we're using Cloud Init to do the majority of the heavy lifting on the software side and the setup of it. I'm really hoping I get to see software components and other things in there. Obviously we do have Puppet capability as well, so you know, seeing some people do some things with that would be really, really cool. Now I'll move on to, I won't really cover extensibility too much. It is in beta for IA, but this is essentially your EBS, being able to trigger workflows. But not only does it allow us to trigger workflows, it also allows us to use Lambda and trigger events. And we can see there's a couple actions that are already in here. We can see that it creates a Python and does what we need to do. So, close that. From here we can actually add new actions, and we can have, you know, what are we going to be? We go my one. We can have a template, custom script action. We can import a package. We can write a script on the fly, or we can add in workflows to run. Oh, not adding workflows. Yeah, so you create new subscriptions. You say what event you want it to run on. You know, computer provisioning, subscription lifecycle, compute provisioning. We can give it, you know, whether we want to filter events, we want to be blocking. We can tell it whether we want to run an ABX, which is Lambda based action extensibility, or we can do our VRO extensibility. And then we choose the action or the workflow from VRO that we want to run. Just like you would in EBS, but you know, we're getting a bit more choice, and it's going to be some pretty cool things that people are going to be able to do with it. Currently in beta though for initial availability. Then we've got Marketplace. So Marketplace has a few items in it at the moment. It's going to continue to grow, but what's really cool is it's a starting block. You know, it can get you in there, get you running. You know, Apache servers using Puppet, WordPress, Ruby, Hadoop, multi-node cluster, those sort of things. So, you know, bring it in, have a look, see how it works, and yeah, go from there and create your own. So really that's pretty much it. The resources bit that I didn't really look at previously is all our compute, all our network, all our machines. And what you'll actually find under the machines is that you can see the ones that it's provisioning or deploying. You can see the ones that it's discovered that are within my data center, within my AWS endpoints, Azure endpoints, etc. That weren't necessarily part of Cloud Assembly, and same with the volumes. You know, brings back all the volumes, whether it's deployed here, whether it's been discovered. So cool. You know, nothing much to that one. Alright, so I think that's it. Again, a very quick overview. Obviously, you know, you could really dive in here and spend some time. Watch out for some new videos. This is some pretty cool stuff. I can't wait to see what you guys do with it out there. And I'll see you next time. See you back.